Welcome everyone to .NET Enterprise Developer Day EMEA 2022. Thank you so much for joining us today. It is my pleasure to introduce to you our next speaker, Francois, Senior Developer Advocate at Amazon Web Services. Welcome, Francois.
Hi, Eric. Thank you for your introduction. And hi, everyone. I'm happy to be here today with you. We put a lot of energy to prepare this event and really happy to be there. So today I will discuss how to build a cloud native application with .NET and AWS. And to be honest, for a while I've been quite uncomfortable with what is a cloud native application. I've heard a lot this buzzword. I would say at the beginning I was thinking it was buzzword. What is cloud native application? And I was really uncomfortable with this. And so today I will start by discussing what is a cloud native application. What is the definition of cloud native? Because I think if I was able to ask you the question, we would have many different answers to this. So let's build a common definition, at least for this session. Then I will, based on this definition, I will build an architecture for an application based on a business use case to see how we can build a cloud native application to solve a business use case. And finally, we will build together this cloud native application because I really want to build live with you a cloud native application just to show that it can be very quick. It doesn't need to be very complex. So let's start with what is a cloud native application. So I think the best way to start by to define what is cloud native is to rely on the definition of the Cloud Native Computing Foundation. I think they are there for this. So let's read together their definition of cloud native. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Container, service meshes, microservices, immutable infrastructure, and declarative API exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. So there are a couple of important things in this definition. First, containers exemplify what is cloud native technologies, but containers are not defining what is cloud native. I've heard a lot about this confusion. Yes, if you are using containers, you are building cloud native application. No. If you put a big monolith inside a container, you are not building a cloud native application. First, so containers are important to cloud native technology, but it's not a requirement and it's not a golden ticket that say, okay, you are doing containers, so you are doing cloud native application. No. What characterizes cloud native application is rather in the second part of this definition. Because using cloud native technologies allow you to build systems that are loosely coupled, resilient, manageable, and observable. And these are the characteristics of a cloud native application. A cloud native application is an application that is loosely coupled to other applications, resilient, manageable, and observable, and leverage cloud native technologies from public, private, or hybrid cloud. I think it's the best way to understand what is a cloud native application. So now that we have this common definition, let's see how we can apply this definition to build a cloud native application on a business use case. So here we are, for the business use case, we are relying on the business use case of I Love My Local Farmer. So I Love My Local Farmer is a fictional online marketplace that allow customers to buy fresh products to farmer, so buy directly fresh product to farmer. You can learn more on the story of this online marketplace on ilovemylocalfarmer.io. So why a fictional company? Because we have a lot of public reference, of customer public reference, but of course, when we share a public customer reference, we share high-level overview of what they did on AWS. They don't want to share their secret sauce, and that's totally normal. You don't want to share your secret sauce. So here, developer advocates, solution architects at AWS, we have gathered a lot of experience on using AWS, and we want to share with you all this experience. So we thought building this fictional company and telling the story of their journey from their own corporate data center to AWS was worth the story. So you can learn more on ilovemylocalfarmer.io. And today we will focus on one of the business process. So when a farmer wants to register on the platform and start selling their product on the platform, they have to register and to send to ilovemylocalfarmer proof of address documents. Okay, so right now they send these documents by mail, and human operators process these documents manually and then store the document in a proof of address database. Okay. ilovemylocalfarmer business stakeholder wants to automate as much as possible this process to be able to reallocate their workforce on more valuable tasks. So let's see how we can build a cloud-native application to solve this business problem. So the application we will build start with a web app. So farmers will navigate to a web application, a .NET web application that we will host on AWS Appreneur. So AWS Appreneur is a fully managed service that runs for you your application in container instances. So the service manages the load balancer and manage the fact to start your container instances, to spin up new container instances if there is a traffic peak, and you don't have to care about managing the server, managing the load balancer. It's all done for you. Once a farmer has reached the website, the first thing they want to do is to log in. And here again, we don't want to manage our own authentication and authorization system and to manage our users database inside our SQL Server database like we have done for many years. Here we do rather want to use a user store, an external user store. So here we will use Amazon Cognito, a fully managed service to manage your user store and authentication and authorization. And we will get our .NET Web App will get we'll check the user credential and permission. And once the user, the farmer, is logged in, okay, we will retrieve pre-signed URL so that they can upload their document to Amazon S3. So what is Amazon S3? Amazon S3 is an object storage service fully managed with high durability for your object. And here, I would say in a traditional way, we would upload the farmer's documents on our web server and then copy the document to a file storage. Here, what we want to do is to send back to the farmer a pre-signed URL to Amazon S3, our Amazon S3 bucket, so that the farmer can upload directly his document to Amazon S3 and into the bucket. Okay? And when we get this pre-signed URL, we don't want to get this pre-signed URL with generic credential. We want to get a pre-signed URL that is generated with user temporary credential, so that when the farmer upload his document to the bucket, we know that it is this farmer who has uploaded this document into the S3 bucket. So we will get a temporary credential for the farmer from Amazon Cognito. Once farmers' documents are uploaded on our Amazon S3 bucket, we want to send a notification to a queue, okay, to decouple our system, and then a background task will consume this message and process the document. So here we will use Amazon SQS, so Simple Queue Service, to as our queue service. It's a fully managed queue service. Here again, you don't have to manage any server to update servers to update your queue middleware. No, it's all managed for you. And for running our background task, we will use Aws Lambda, serverless compute systems that allow you to execute your code without without managing any server here again. So AWS Lambda, our AWS Lambda function will call Amazon Textract, a machine learning service, to analyze the document and retrieve important data from the document. So here again, it's a fully managed service. You don't have to train your own machine learning model. It's all built for you. So you retrieve the result of the document analysis, and then we will store the real results of the document analysis inside our Amazon DynamoDB NoSQL database. Okay. So here again, fully managed service. You don't have to care about you don't have to care about managing servers. So here we are. We have the architecture of our cloud native application leveraging public cloud technologies, and it allows to our system to be resilient, observable, because all these services are fully observable and you can monitor them. So let's see now how we can build this application. Okay, so let's jump into Visual Studio. Okay, so here I've pre-built and pre-created a Visual Studio solution based on the default .NET web app template. So I will build the application and just launch the application to show you that it's really the default .NET web app template with the login page scaffold. Okay, so I've just used the scaffolding feature of Visual Studio to scaffold the login page. So here you can see I've scaffolded the login page, and it has created DB context to store my user inside a SQL Server database, but I don't want to use this. So let's launch the web app just to check it works, and it's really the default template with the login page scaffold. So here on my laptop, I launch my .NET web app through Docker, so everything is okay. I love this. First, live demo issue. Let's fix this. Okay, let's rebuild the solution. Okay, it should be good this time. I've already had this issue, and rebuilding the solution make it works. Okay, so I'm all good. So here is my .NET web application. It's really the default template. I can click on login. I see my login page. That's it, the default template. So now let's change this default template to rely on Amazon Cognito to store my users rather than my SQL Server database. So to do this, I will first start by adding a NuGet package called ASP.NET identity.cognito. Okay, so let's install this package. So here with this package, we have built an extension to the identity provider model, so based on Cognito. So we've implemented the identity provider model using Cognito as the underlying user store. Once I install this package, I can go into my program.cs file and remove everything related to Entity Framework. So here I can remove this, I can remove the namespace, I can even remove the unused using statements, and now I just configure the dependency injection for using Amazon Cognito through the identity provider model. I just had to call this add Cognito identity extension method, and I'm done. Okay. So next things to do is to change the login partial page here, because I don't want here to use the identity user default object, but rather the Cognito user object. Let's fix the using statement. Okay. And we have to do the same modification in the code behind the login page. Okay, here we want to use the Cognito user. Also, okay. Good, and I can even remove the unused. Okay, so I'm good now. So now, so that my extension, my Cognito extension, know how to with which Amazon Cognito user store it has to work, I need to enter some settings. So here I'm using, as I'm working with container, I prefer to set up these settings through environment variable. So I will go into my launch setting.json file and add a few lines here to define my environment variable. Okay, and here we go. Let's really prepare what is needed here. So first, just to a quick explanation here, I'm adding this Dockerfile run arguments, so that when I launch my container, I mount my AWS credential folder into my containers, because when I run my application locally, the .NET SDK will look for a credential to connect to Amazon Cognito API for the first connection, to interact with Amazon Cognito API. So I need to have some credential set up somewhere. So here if I run my container instance as it is isolated from my file system, the .NET SDK won't be able to find my credential folder. So here I need to mount my credential folder into my my container instance. So this line is quite important. Then I'm defining my environment variables. So here, which AWS profile to select and to use inside my credential folder. And then the AWS region where my Amazon Cognito user store is deployed, and the user pool ID, and also the user pool client ID and client secret. So the good question is where to find this information. So let's navigate into the Amazon Cognito console. So here is the Amazon Cognito console. Here you can see that I've already created a bunch of user pools. Let's navigate into my local farmer -dev. It's the user pool I'm using for this demonstration. So in my user pool, you can see that I've already created one user, so with my email address. And here I can find the user pool ID. So this is the value I've used in my environment variable. And here I can click on the App Integration tab, okay, and scroll down and go to my client application. So I've declared a client application for this user pool. I could create other client application. Here I need just one client application. And here I can get my client ID and I can show the client secret, okay? So here are the, where are the info I need to set up my, my application and my settings, okay? So let's now, let's start the application. Everything should be good. So let's rebuild my application to avoid the same issue as previously. So I rebuild my application and I will launch it, and I should be able to log in with my user already created in my Amazon Cognito user pool. So let's launch the application. Okay, so my application has started. I can click on my login page. Here I can use my email address, type my password, and click on login. And it works. Here you can see it displays my name. And if I get back into the AWS Cognito console, if I click on my user, you can see that I've filled the name attribute. And here I'm displaying the name attribute in my application here. So now I'm logging. I'm able to log in my user thanks to Amazon Cognito. It was quite straightforward. Not much to do. Sorry. So let's go back into Visual Studio. So the next thing that I want to do is to get a pre-signed URL to allow my user to upload their documents directly into my Amazon S3 bucket. So let's do this into the index page. So just to let you know, I'm not a front-end web developer, so I won't build a nice user experience. Please be kind with me. I just want to show you what's going on under the hood, but for the front-end part, be nice with me, be kind. I'm not a front-end developer. So first things, I will need to check if I'm signed in or not. So I will add here sign in manager. So let me check. Yes, sign in manager. It's a private read-only sign in manager. And we will use here so a Cognito user. So let's fix this. Okay, so I will use the sign-in manager to check if the actual user in the session is logged in or not. And I will also need some settings. So I will also need a configuration object. So let's add this into let's add this into the constructor. Okay. I love Visual Studio completion. Makes my life easier. So, okay. So now I want to check if my user is logged in or not. Quite heavy with the sign-in manager. I just need to use this is sign-in method with the session user. So if the user is signing with Amazon Cognito, I want to retrieve the Cognito user ID. So it's quite easy to do this because I just need to grab the name identifier claim inside the user claims. So that's quite straightforward. And once I've did this, I want to generate a key for the file it will the farmer will upload. I don't want to use the file name of the user. So here I generate a key. So in an Amazon S3 bucket, the key is the equivalent of the file name. So here I generate a key with the composed of the cognito ID and a timestamp. Okay, and here I'm retrieving the bucket name from the configuration where I want to upload my document. So that's it. And now I need to retrieve the cognito user. Cognito user. So here I'm using the sign-in manager, okay, to find the cognito user by its name. So here it's cognito ID. So be careful. Here I'm using an asynchronous method, so I need to change method signature to avoid any issue. So here I've retried the cognito user, and once I've retried the cognito user, I will retrieve temporary credentials for this user that will allow me to interact with AWS services on behalf of this user. So here, let's resolve using statement. So here, I'm using on the cognito user, I'm using the get cognito AWS credential on this cognito user, giving this method the identity pool ID that I need it needs to use and the Amazon region. So what is an identity pool? So let's navigate once again into the AWS console. So here in the Amazon Cognito console, you see that I have the user pools feature and the federated identities feature. So let's click on the federated identities. So here I have two identity pool. I can click on the proof of address identity pool here, and I can edit this identity pool. So basically, an identity pool allows me to define for what I need to do for unauthenticated role and for unauthenticated user and authenticated user. So for authenticated user, my identity pool will link to these users a role, an IAM role. So IAM stands for Identity and Access Management. So I will link to my unauthenticated users an IAM role that may allow them to interact with some AWS services, even if they are not authenticated. And for authenticated user, I will link another role, granting them more permission. So here I've already pre-created this role, and the role for authenticated user grants them the access to grant them the permission to get a pre-signed URL and to upload documents inside my Amazon S3 bucket. And here in the authentication provider, I can set up to which provider I linked this permission. So basically here I've set up my user pool ID and my app client ID, okay? So think about user pools and identity pools. Like user pool manage your authentication, and identity pool manage the authorization of your user with regarding AWS services, okay? So I've grabbed my identity pool ID from there, and I've set up the identity pool in my environment variables here, okay? So let's go back into my file. So now I have a temporary credential for my logged in user, and I can generate pre-signed URL for them. So let's generate a pre-signed URL. So let's define the pre-signed URL as a bind property so that I can use this on the front-end code. Okay. Yes, I'm using the latest version of C#, so it doesn't like that I don't initialize my pre-signed URL inside the constructor, and now I need to generate my pre-signed URL. First, I need to add a package to allow me to interact with Amazon S3. So let's search for AWS SDK.S3. So let's install the latest version of the package. Okay, and now let's create this generate pre-signed URL method. Okay. So now the method is there. What I'm doing in this method, so I'm creating an Amazon S3 client object. So you will find this pattern with all AWS services inside the SDK for .NET. So for each AWS services, you will find a client object that allow you to interact with AWS services. So here I'm building an Amazon S3 client object, and I'm passing my temporary credential as parameter, so that it will interact with Amazon S3 on behalf of my logged in user. Then I'm creating a get pre-signed URL request. So here again, for each API you can call on AWS services, you will find this pattern. On the client object, you will find a method to call the API, and the method will take as a parameter request object. So here a get pre-signed URL request object, in which I set up every parameters of my API call. So the bucket name, where it need to, for which bucket it needs to create a pre-signed URL, for which key, so which file name. So here for which HTTP verb. So here I'm indicating that I want to allow only put HTTP verb. So user will only be able to upload document, but not to retrieve them. An expiration duration, and a content time. So if user try to upload something else at a JPEG file, it will fail. Okay, and that's it. I'm all done with how I can retrieve my pre-signed URL and allow a user to upload their document. Oh no, I need to change the front-end code. So let's do this. So as I told you, I'm not a front-end developer. So here I will copy paste some code here. It's probably not the nicer user experience you will see, but it works just for demonstration purpose. So here I have a file input and an upload, a button that will trigger the upload event. And in my own upload function, I'm using my pre-signed URL to upload my document into my Amazon S3 bucket. So now it should be good. Let's rebuild the solution and let's launch our application, and let's try to upload the document into my S3 bucket. So before doing this, let's go into the AWS Explorer. Let's see all my S3 bucket, and here I'm using the bucket name my local farmer proof of address live. Okay, so let's check that this bucket. So as you can see, I can interact with some AWS services directly from Visual Studio. I don't need to navigate to the AWS console through my web browser to interact with Amazon S3. I can double click on my bucket here. It opens a nice view where I can browse the content of my S3 bucket directly from Visual Studio. So here I can click on refresh. Okay, my bucket is empty. Okay, so now my build is successful. Let's launch the application and let's try to upload our document into the S3 bucket. Sorry. Okay, so let's log in first, of course. Good. So as you can see, wonderful user experience. Let's select my file and let's click on upload. Okay, I don't get any error message, so it should be good. Let's check the content of my S3 bucket, and my file is there. Uploaded directly into my Amazon S3 bucket without requiring to first upload my document onto my web server and then copy my document on file storage. I've uploaded directly my document into my S3 bucket in a secure way. Okay, so I'm done with the web application part of my application. So now that my document is stored in my S3 bucket, what I want to do is to trigger a message and send a message to a queue. So I need to create a queue. So let's create an Amazon SQS queue directly from Visual Studio. I can do this, create a queue. Let's give my queue name, my local farmer proof address live. Okay, I can set up the default visibility timeout, the default delivery delay. I don't want any delay for the delivery. I could configure a dead letter queue. So for the sake of the demonstration, I don't want to do this. Okay, and I click OK. And that's it. I got a queue, and it's already up and running, and I can work with it. So now what I want to do is configure my S3 bucket to notify my queue that I've uploaded some documents. So let's configure my S3 bucket and the notification of my S3 bucket. So yes, remove this one. So let's add a new notification. Okay, so here I want to send a notification for the object created event to Amazon SQS. Okay, and I don't want to send a notification for every object created inside my S3 bucket, but only for the object created under the upload folder. So let's add this prefix and let's click OK. And that's it. That's it. I can upload a new file and we will have something in my queue. So let's see here, my queue is empty. Okay. Let's upload a new document. Let's upload a new document. And let's go back to my queue. Okay. So here. Oh, yes. I think I know what's going on there. Let's first delete this. Yes, because the document already exists. Okay, sorry. Let's upload the documents. Okay. Let's refresh. My document is there. And now if I go back to my queue, let's refresh. Okay. Demo effect. More than happy. Maybe, oh, I probably missed something. Oh, yes, I missed something. I didn't create the notification for the right queue. Okay, let's do it once again. Sorry about this. I've been a bit too quick. So here, I didn't select the right queue. So let's add the prefix. Okay, should be all good now. Oh no, I have a message. Okay. So here I have a message, okay, indicating that I have an object has been created into my S3 bucket. So now I want to consume this message. So I need to create an AWS Lambda function. So pretty easy to do this inside Visual Studio. I just need to, create a new project. I will use the AWS Lambda project template. To get this template, you just need to install the AWS toolkit for Visual Studio, and it will add this template for you. Oops. Background task. Okay. And here I can select a blueprint. So I could create an empty function, an empty top level function. And here I want to use the simple SQS function. So we provide a blueprint that is dedicated to create an AWS Lambda function that will consume SQS message. Okay. So that's it. Finish. So if I open my function.cs file, let's make this larger. So this is the function handler is my entry point. Each time my AWS Lambda function will be triggered, this function handler will be called. So here, my function handler process every record, so every message in the queue, because it can consume a message in batch mode. So here it's the loop consume every message, and in the process message async, this is where I need to put my my code to process the function. So let's do this. Let's code here. So I need to fix some using statements. And here I'm missing the analyze document and store analysis result. So I need to copy paste this this method. So the analyze document is the method that will call Amazon Textract. Okay, so let's add this to our code. First, I need to, of course, install some NuGet package. The NuGet package that allow me to interact with Textract, and the NuGet package that will allow me to interact with DynamoDB. So let's install both in once. Okay, and DynamoDB. Yeah. Okay, nice try. So the search is giving me. Okay, let's install this package. Okay, so now I can resolve all this using statement issue. Okay, here again. Okay. String builder. Okay, let's using statement. Perfect. So now let's take a look. So the same pattern here. I'm using my Amazon Textract. I'm creating an Amazon Textract client. I'm building an Amazon an analyze document request. Here I'm just setting the fact that, okay, you what I want you to analyze is my document in my S3 bucket, okay? And I want you to run forms analysis, forms document analysis. And I just call the analyze document async method. So Amazon Textract will retrieve key value pair inside my document. So basically, inside my form there is a key called first name with my first name, Francois. It will retrieve the key and the value. I need to retrieve all these key value pair. I need to path Textract results. To do this, I've just copy-paste the algorithm given in the Textract documentation. So I won't go into the detail of the get key value method and key value relationships. It's copy-pasting of the AWS Textract documentation, okay? And finally, I need to store my document into my DynamoDB. Okay, so let's copy paste this method. So here again, I'm doing same pattern. I'm creating an Amazon DynamoDB client, okay? And here I'm creating a document model and table from the proof of address table. So the proof of address table is already created into my AWS account. Here it is there. So I can double click on proof of address, scan my table. My table is empty right now. Okay, so that's perfectly fine. And I'm just putting an item into my table. Okay, pretty straightforward. So that's it. My AWS Lambda function is done. So let's deploy it. First, let's build my solution. And then let's deploy it. So here I do a right click, publish to AWS Lambda. And here I will select that I want to run my AWS Lambda function on ARM processor because it will be cheaper. Let's call my function background task. Next. So that my Lambda function be able to interact with Textract and DynamoDB, I need to provide my AWS Lambda function a role that allow it to interact with these services. So I've already created the role for, before the demonstration. So I set up the role, and now I can click on upload, and it will package my Lambda function and upload it to AWS and create an AWS Lambda function with my code. Okay, it will take a few seconds. It's pretty quick. It is zipping my archive, and that's it. It is creating my Lambda function. Okay, that's it. It's active. It's running on ARM processor. Pretty cool. And now I just need to configure my event source. So here my event source is my Amazon SQSQ, the live one, and let's click on OK. Oh, okay. There's already mapping for this. Let's fix this quickly in the console, because otherwise I won't be able to demonstrate what I want to demonstrate. So let's figure this background task. Okay. So configuration, triggers. Okay. Okay, the triggers. Oh, I didn't delete the trigger before when I've rehearsed. So let's reactivate this trigger. I can reactivate the trigger and it will work. So perfect. So when I was preparing this demonstration, I've already created this trigger with the same name. So the trigger was still there. Okay. So I just need to reactivate this trigger and it's all good. So now I can launch once again my application, upload a new document, and we will see the end-to-end workflow. So let's log in. Okay, let's log in. Perfect. Let's choose a file. Let's upload it. And now let's go back into my proof of address scan table. It may take a couple of seconds. So let's see if I got a message there. Yes, it is currently processed. So let's go back here. And that's it. I got my results inside my Amazon DynamoDB table. Okay, so I'm done. Right on time. I've built everything I wanted to build with you. So let's quickly wrap up. So what we've seen, you can easily build and host your .NET application using AWS services. You don't need to manage any servers. You can leverage serverless and container services to run your .NET application, and you can interact with AWS services directly from your favorite IDE. So what we haven't seen in this demonstration, we still need to fine-tune permission to apply least privilege policy. We need to add monitoring to our application, leveraging CloudWatch and X-Ray. And we also need to automate deployment and data of our infrastructure, leveraging infrastructure as code. So we still need to do this. So a few key takeaways: leverage the AWS Toolkit for Visual Studio, the AWS SDK for .NET, and our serverless and container services. So I give you some links here, and you can try .NET on .NET on AWS. Please try it. I will soon publish the source code of this demo on GitHub, so I will announce it on my Twitter and LinkedIn account. So please follow me on Twitter and LinkedIn, and you will be notified. Thank you for your time, and I hope you enjoy the session, and you can join me on the virtual booth of AWS. I will be happy to answer your question.